Assalamu alaikum dear students, this is Wajid Ali Shah and today we are going to explain the topic resonance in AC circuits. Dear students, what is resonance actually? Resonance is actually the increase in the overall current of the circuit. This is what we call resonance for electrical circuits. As we know from the impedance equation proved in the previous lecture that Z is equal to R square plus XL minus XC whole square root. This is the equation for the impedance of the circuit. For the resistance of the overall net resistance is also called impedance, which can be shown by the alphabet Z. Where XL have been found that XL is equal to omega into L, where omega is used for frequency and L is used for the inductance. And also Xc is equal to 1 over omega C. Omega is the angular frequency and C is the capacitance. These two equations have already been proved in the previous lectures. Dear students, when we know that the frequency of AC is small, so having these two equations in mind, we can say that Xc is large when frequency is small. And the next step is when the frequency is large, so XL becomes large, inductive reactance becomes large. And third point, when XL is equal to XC, it happens at some certain frequency. These two are cancelled out with each other, having same value, so they will be cancelled out, and the overall net resistance or the impedance will become minimum. Z will become minimum when these two cancel out. So we have Z is equal to R. So that time the circuit is called resistive circuit. So when Z is minimum, so the current reaches to its maximum value. As we know from Ohm's law that current and resistance both are inversely proportional to each other. So when the net resistance of the circuit decreases, minimizes, so the current increases and maximizes itself. So at this stage it is called the resonance in AC circuit. Now, what is resonance in RLC series circuit? Specifically, we are talking about RLC series circuit. So as we know that the resonance happens when XL becomes equal to XC. So omega L is equal to 1 over omega C. Having a previous knowledge of the omega, that from class first year chapter number 5, we knew that omega is equal to 2 pi f. So putting this value of the omega 2 pi fl, instead of omega we have put the value 2 pi fl and again omega 2 pi f into c. So rearranging this equation and simplifying the equation, we can have frequency is equal to 1 over 2 pi lc under the root. This is what we call resonant frequency. This is the frequency at which the resistance of the overall RLC series circuit minimizes and the value of the current increases to its maximum value. So this is the resonant frequency equation, and we can explain the curve like the graph for resonance here. Along x-axis we can take the frequency, along y-axis we can take the current I. So for large R, the current is minimum. The overall resistance of the RLC circuit is, if it is large, so the current will be minimum. And for example, the resistance of the RLC series circuit is small. If the resistance is small, so current increases to its peak value, its maximum value. And this happens at some certain frequency, and that frequency is called the resonant frequency. An equation for the resonant frequency can be given as f is equal to 1 over 2 pi LC under the root. Thank you. Have a nice day.